Hey guys, I decided to just go ahead and make a video recording of the solutions for the current assignment, assignment 10. So, you can watch it or you can just scoot ahead and watch parts of it or whatever you want to do. All right, so let me just start with number 1. So we've got, oops, let me get my pencil. Okay. Quantity 4x squared y squared times quantity negative 3x y to the fourth cubed. Okay, so when we see these outside exponents, that means that we have to distribute them to everything that's inside the parens. All right, so for example, for this first part, then we're going to have 4 squared and then times x squared squared and then times y squared. And then all of that is times, okay, and in the second set of parens, we have to distribute the outside exponent of 3. So everything that is inside there has to be cubed. So negative 3 cubed times x cubed times parens y to the fourth cubed. All right, and then we'll just go through and start simplifying each of these. 4 squared, of course, is 16, okay, times x squared squared, okay. So when we have, one exponent and then it's raised to another exponent, we have to multiply those. So in other words, I'm going to do 2 times 2. All right, so that's going to be x to the fourth. And then y squared. Negative 3 cubed. So negative 3 times negative 3 times negative 3 is negative 27. All right, and then x cubed. And then again, we have another case here where we have something to a power, to the fourth, to another power, the third. Okay, so again, we multiply those. 4 times 3. So that's going to be y to the 12th. Okay, now we look to see, what things we can combine, what things we can multiply together. We can multiply the 16 times the negative 27. That equals negative 432. We can multiply the x to the fourth times the x to the third. Okay, and when we're multiplying x to the fourth times x to the third, that's where we add the exponents, 4 plus 3. Because it means here we have 4 x's, x, 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 x. Here we have another 3, x, x, x. So together we have 7 of them. So negative 432, x to the 7, and then same thing with the y's. Here we've got y squared and y to the 12th. So just add the exponents. We have a total of 14 y's. Y to the 14. Okay, so that is your final answer right there. Negative 432, x to the 7, y to the 14. Okay, I'm going to erase this and go on to the next problem. All right, I'm going to give myself a little more room on this one too, just by doing this. Okay, now I severely regret having put this problem on the assignment. My apologies. I know it caused people a lot of pain. So let me say, there's a number of different ways that you could start on this one, okay? And let's see, in hindsight, I think the easiest way before we deal with the outside exponents is to simplify the expressions within the parentheses. All right, so for example, let's start by looking at the first parenthesis. Okay, we have 1x on top and we have 4 x's on the bottom. All right, so that is like saying we've got x up here, oh sorry, and we've got x, 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 x down here. Well, x over 4 x's, I mean, you can get fancy schmancy and use the quotient rule, or we can just say, well, one of these x's cancels one of these x's, leaving us with just 3 x's in the denominator. All right, so in other words, let's start rewriting this expression. The 3 and the 4, there's nothing we can do to reduce that. But we can get rid of this x, and then in the denominator, we just have an x cubed. Okay. All right, now let's see what we can do with the y's. I'm going to erase this other stuff up here. All right, what do we got going on with the y's? So first of all, in the numerator, we have a y to the 1. In the denominator, we have a y to the negative 3. Okay. Now, if you recall from the negative exponent definition, if you have something like 1 over a to the negative n, you can just flip that up to the numerator, flip it upstairs, and make the exponent positive. So that's the easiest thing to do here. Just take this and move it up to the numerator and make it positive, y to the positive 3. So in other words, now in the numerator, we have y to the 1 times y to the 3, the positive 3. Okay? And then if you combine those, then you end up having y to the 4. Okay? So this ends up, let me make this line shorter, simplifying greatly this initial expression. So now we just have, one grouping of 4, one grouping of y's, one grouping of x's. It's all this stuff squared. Now let's look at this second expression, because we're going to take this first one times the second one. So the key thing here is that we have this outside exponent of negative 1. Now, the rule here is if you have, say, a over b to the negative n, negative exponent, then you can just flip everything inside. Sorry, I have no idea what just happened there. Flip everything inside the expression and make the outside exponent positive. Nothing changes in these inside expressions. You are literally just flipping the numerator and denominator, and then the outside exponent becomes positive. All right? So if we do that, I'm just going to take this stuff, put it on the top. 8x cubed, y to the negative 3. And then take this stuff, the numerator, and put it on the bottom. 9x, y to the 4. And now that's going to be the positive 1. I'll go ahead and write that, which just means nothing, really. We could really just get rid of that 1. It's just this expression. Okay, now next step, let's simplify inside here, because again, we can combine the x's and we can combine the y's. All right, so I'm just going to recopy this. So we're going to have 3y to the 4th over 4x cubed. All right, quantity squared. Okay, now what is going to happen inside here? We've got an x cubed over an x. Well, that can be simplified because xxx over x is just going to leave you with x squared in the numerator. So we can make that change to start. Okay, nothing is going to change with the 8 over 9. Let's just write that in. But then we're combining the x's, so we're going to have x squared. And then the y's, what do we got going on? Well, we have a y to the negative 3 here. So we're going to use the other form of the negative exponent rule. If you just have a to the negative n, that's the same as 1 over a to the positive n. So in other words, we're going to take this y to the negative 3 and move it down to the denominator where it would become y to the positive 3. Okay, so now we've got y to the 4 times y to the 3, which is going to become y to the 7 in the denominator. All right, so we've greatly simplified this second expression. All right, the next thing we need to do is to deal with this outside exponent here of the 2. Oops, I meant to change to highlighter and I didn't. Undo. Ha. All right, we need to deal with this outside exponent of the 2 by distributing it to every single thing that's inside here. Okay, so let's write out our next step. So we're going to have 3 squared. We're going to have y to the 4 squared. And then over 4 squared, x cubed squared. All right, and so then all this times everything in this second expression is going to remain the same. I'm just not going to rewrite it. Okay, so next step, starting to simplify this stuff. All right, so 3 squared is 9. Y to the 4th squared, multiply the exponents. It's going to be y to the 8. Over, okay, 4 squared is 16. X cubed squared, multiply the exponents, is x to the 6. And then at this point, you know, we're just going to be multiplying all this stuff by all this stuff. So let's just write it like that. Okay, so what did we have in the second set of parens? Well, we had an 8 and we had an x squared. And what did we have in the denominator? We had a 9 and we had a y to the 7. All right, now I think what some people were just forgetting at this point, we can just kind of move stuff around up here. So let's just do that to make it more clear. I'm going to move my 8 up to the front here. So I'm going to just move and have 8 times 9 times, and then let me just put the x's, the x squared times the y to the 8. Over, all right, now I'm going to keep the 16 here, times 9 times x to the 6 times y to the 7. Okay, now do you see why I wrote them in this particular order? Because now we can easily see how we can just cancel stuff out. 8 over 16, well, you can take a factor of 8 out of both of those. This leaves me with a 1. This leaves me with a 2. 9 over 9, that just equals 1. Just cancel them. X to the 2 over x to the 6, that just leaves me with x to the 4 in the denominator. Y to the 8 over y to the 7, that just leaves me with a plain old y to the 1 in the numerator. All right. So now, if I go across and just see what's left, well, just a 1, which I don't need to write, and a y. So just a plain old y in the numerator. And in the denominator, I've got 2 times x to the 4th. 2x to the 4. All right. So that would be your final answer for this one. So it's important to just be meticulous and do things one step at a time. Try to make things easier on yourself. When you have an outside negative exponent like up here, you never ever want to actually distribute that, because then you're just literally distributing confusion. Okay? Get rid of the negative exponents. Even on the inside, just get rid of those negative exponents right off the bat. Okay? It's just easier to work with positive exponents. All right, I'm going to erase this and move on to the next problem. All right, and these went very well, but just to make sure, the scientific notation. All right, so on this one, the decimal needs to go right here, right after the 5. 5.62, because you always want exactly one digit, one non-zero digit to the left of the decimal point. And then, just count by making the loops, 1, 2, 3, etc. I won't go the whole way. But it turns out you have to move it 9 times. And this is a very small number. So therefore, we know it's going to be times 10 to the minus 9. Okay. On this one, the decimal starts here. It has to end up here. Okay, it's got to be 3.98. All right, and then 10 to the what? Well, we know it's going to be a positive exponent because this is a very big number. So just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 3.98 times 10 to the positive 11. All right, going to erase and move down. Okay. I think on this one, on these two, really nobody had any problems. okay, on this one, let's just remember that it's negative, but let's not worry about that for now. But if you started by writing 7.492, and because this is a negative exponent, it's a small number. So we know we need to move the decimal to the left. So just count 7 loops. 1, 2, 3, 4, 5, 6, 7. There's your new decimal place. Fill in each loop with a 0, 0, 0, 0, 0. It's always good form on these decimal numbers to put a leading 0, and don't forget the negative sign. Okay, so that has 6 zeros. This one, you put the decimal point here. It's a big number, so you're going to be moving this way 6 times, which means you're adding 6 zeros. So the final number is, it's actually 5 million. And, you know, it never hurts on the really big numbers like this to add commas. Remember, every 3. Starting from the right-hand side. 1, 2, 3, comma. It's just visually is easier to read the number. All right, I'm going to erase and move down. Oops, not what I meant to do. All right, on this one, just multiply 2.5 times 1.4, which is 3.5. And then combine 10 to the 5th and 10 to the 7th. So in this case, just add the exponents. 5 plus -7 is -2. So it's 3.5 times 10 to the -2. And I specified in the instructions, because this is what our book says, write your answer in decimal form. All right, so take it out of scientific notation. It's -2, so you got to go 2 positions this way and add a 0. So it's 0.035. All right, 5b, 9 divided by 4.5 is exactly 2. And then that's going to be times 10 to the, using the quotient rule, looking at the exponents, it'll be 10 to the 12 minus 9, or 10 to the 3. Again, change that to decimal form. Here's where the decimal point is, and we got to move 3 positions this way, 3 loops. In other words, add 3 zeros. So that becomes 2,000. Okay. All right, going to erase and move. All right, on number 6, okay, the key is distribute, distribute, distribute. Be careful with your signs. All right, so we're going to start by doing -6 xy squared, and then times x squared, that's the first term. All right, for the second multiplication, notice that this is negative and this is negative, so it's going to turn into a plus. So we're going to do plus 6 xy squared times 10xy. And then on the third multiplication, negative times positive, so it's going to be negative. So minus 6 xy squared times 3y squared. Okay. All right, let's come back here and tidy this up. So here, the coefficient is just going to be -6. And then we want to multiply the x's. And so we've got an x to the 1 here, and then x to the 1 times x squared, just add them. I've got one of them, and then here's another two of them, so now I've got three of them. So minus 6x cubed, and then just y squared. All right, plus, okay, 6 times 10 is 60. And we've got x to the 1, x to the 1. All right, so that x times x is x squared. And then I've got y squared times y to the 1. So that is going to become y cubed, just adding those exponents. Or just thinking more generally about how many y's there are. All right, and then minus, okay, 6 times 3 is 18. And we've got, well, we've just got one plain old x. So it's just going to be minus 18x. And then y squared times y squared is y to the 4th. And that would be your final answer. None of those are like terms. You cannot combine any of those. All right, let me move on to number 7. Okay, so this is one where we need to FOIL it. Okay, remember first, outer, inner, last. So here's the first, outer, inner, and last. So the first, x times x. The outer would be the x times negative 3/7 y. So that's going to be minus x times 3/7 y. The inner is going to be, well, it's positive 3/7 y times x. So we could write that as x, plus x times 3/7 y. And then 3/7 y, the last, is 3/7 y times negative 3/7 y. So this is going to be minus 3/7 y times 3/7 y. All right, now what you hopefully noticed right off the bat is that these two central terms here are opposites. Negative x times 3/7 y, positive x times 3/7 y. Okay, these cancel. We can just get rid of them. All right, what do we have left? Well, we have x squared. And then we have this. And let's just rewrite this because I could see some people getting confused. We could just move the terms around. So this is like minus 3/7 times 3/7 times y times y. When you multiply fractions, just multiply the tops. 3 times 3 is 9. And multiply the bottoms. 7 times 7 is 49. And then y times y is y squared. All right? So x squared minus 9 over 49 y squared. All right, that would be your final answer right there. All right, gonna erase and move this down. All right, number 8. Just want to FOIL it again, so let's just draw the lines. First, outer, inner, last. All right, so the first would be y squared times 3y. The outer is going to be y squared times minus 8, so it's going to be negative. So minus y squared times 8. The inner is going to be 3y times 3y, so that'll be positive 3y times 3y. And then the last is 3y times minus 8, so it's going to be negative 3y times 8. All right, let's make another pass through and start to multiply these. So this one we're going to have 3, and then y squared times y to the 1 will be y cubed. All right, and then minus 8y squared. Three y times 3y, so that's going to be 3 times 3 is 9. Y times y is y squared. And then minus 24y. All right, and then what you hopefully see here is that the minus 8y squared and the plus 9y squared are like terms. Okay, they have the same variable, y, and the same exponent squared. So those two terms can be combined, and those are the only two terms that can be combined because those are the only like terms. All right, so 3y cubed. And then think of it this way, we've got plus 9 of them, and then we're going to have minus 8 of them. 9 minus 8 is 1. So we're just left with 1y squared, or just plain old y squared. And then we still have the minus 24y. And then that's it. We cannot combine any more of this stuff because these are not, none of these are like terms. Okay, so 3y cubed plus y squared minus 24y. That is your final answer on this one. All right, gonna erase and go on to the next one. Okay, this one, it's always helpful to write these out so you don't forget what it means. What it means is 1/3 x minus 4 times 1/3 x minus 4. And then we have to FOIL it. Okay, here's first, outer, inner, last. All right, so if we do the first, so I've got 1/3 x times 1/3 x. Outer is going to be 1/3 x times minus 4, so it's going to be negative. So minus 1/3 x times 4. Inner is also going to be negative because it's minus 4 times 1/3 x. And then last, well, it's minus 4 times minus 4, so it's going to turn into plus 16. All right, so back to here. Okay, so 1/3 times 1/3 just multiplying fractions, multiply the tops. 1 times 1 is 1. The denominators, 3 times 3 is 9. And then x times x is x squared. All right, then minus. Okay, so let's come over to this one first. So we can think of this as 4 over 1. 4 over 1 times 1/3. Just multiply the tops, 4. Multiply the bottoms, 3. And essentially, can you see that you have exactly the same thing here? It's just that the 4 is written at the back instead of at the front. So for both of these, we are going to end up with minus 4/3 x. All right, this one is also minus 4/3 x. And plus 16. Okay. All right, and again, we have the two terms in the middle, minus 4/3 x, and then minus another 4/3 x. Those are like terms. Same variable, same exponent, which is just 1. So we need to combine those two terms, which when you're combining like terms essentially just means combine the coefficients. In other words, I've got negative 4/3 of them, negative 4/3 x, and then I'm going to add or subtract, add negative 4/3 or just subtract another 4/3. These are common denominators, so I can combine the numerators over that common denominator. Negative 4 minus another 4 is negative 8. Okay, so I'm just combining the coefficients, but that's all you're doing when you're combining like terms. So that's how many x's I have. All right. So this remains the same, 1/9 x squared. And then minus 8/3 x. And plus 16. All right, and there's your final answer on that one. You cannot do any more combining because none of those are like terms. All right, gonna erase this and go on to the last problem. Okay, so this is another one where first thing you want to do is just write it out. Okay, it means x squared plus 5y times x squared plus 5y. All right, we're just going to FOIL it. This times this. That's first. Outer. Inner. Last. All right, so our first is x squared times x squared. Our outer is x squared times 5y. Our inner is 5y times x squared. And our last is 5y times 5y. All right, let's go through and start cleaning this up a little. So x squared times x squared, just add the exponents. It's x to the 4th. All right, on these middle two terms, hopefully you can see that these are like terms. because they both have the same variables to the same exponents. They're written in the same order. We can fix that. I mean, this is the same as, let's just put the coefficient in the front. This is the same as saying 5x squared y. And this is the same as 5x squared y. So again, just combine the coefficients. Okay? We've got 5 of them, and we're adding another 5 of them, which means that we're going to have 10 of them. Okay? So plus 10 x squared y, and then plus 5y times 5y, so the 5 times 5 is 25. Y times y is y squared. All right, and that's it. Cannot combine any of those because none of those are like terms. All right, that's it for this video. Thanks.